Hello again, Module 4, Lesson 3 homework video. And the objective of this homework is to identify, define, and draw perpendicular lines. You are going to use your right angle template that you have because perpendicular lines form a right angle or a 90-degree angle. And again, remember to use your problem set because the problem set and the homework are almost identical. And remember that today when we were doing the problem set, we only circle in your homework what you completed in the problem set. So this homework video will show the entire homework, but you only have to complete the problems that are circled. Let's begin. So on each of these objects, you're going to trace at least one pair of lines that appear to be perpendicular. Now I only did one, but you might be able to find more. So you have to use either a pen or something dark enough so that we are able to see it. So this creates a right angle on this table. The T creates a right angle in stop. The corner of the computer creates a right angle that creates perpendicular lines or 90-degree angle. The corner of the bookcase, and obviously you can do the other corners and maybe some of the books, but I just did one, but you could do more. So it says at least one, but you can do more than one. In the house, I did the doorway to form perpendicular lines, which make a right angle. On the xylophone, I used one of the, I don't even know what these are called, one of the keys to form a right angle, which is a perpendicular lines. And in the cityscape, I used right here to form a perpendicular line right angle. So how do you know if they're perpendicular? Well, because if two lines are perpendicular, when they intersect and form a right angle or 90 degrees. Now notice this can go longer. This line segment can go longer and this is shorter. So they don't have to be exactly the same length. They just have to form a right angle. So for number 3, it says in the square and triangular grids. So this is a square grids because these are squares, and this is a triangular grid because they're triangles. You're going to use what they've given you, these few line segments, to draw a segment that is perpendicular. Now you should use a straight edge because obviously you have to make a right angle. So I just made a little bit line segment right here to make this a right angle. I made this line segment here to make this a right angle. I made a line segment here to make this a right angle, so it's perpendicular, and I made a line segment here to make this perpendicular or a 90-degree angle. Now for 4, you are going to use the right angle template again to determine which figures have a right angle and mark each right angle with a small square. For each right angle you find, you're going to name the pair of perpendicular sides. So A. For problem A, they did the first example here. Do you see how they made a square? I colored mine in just so you could see them, but they have this. So to make this perpendicular, it would be CA, this line segment, and AB. So that means line segment CA is perpendicular to, and that's the symbol, to AB. So I found another one, AB, BD. So there's a right angle here. So that's AB is perpendicular to BD. So AB is perpendicular to BD. And then here, BD is perpendicular to DC. So BD is perpendicular, and that's why the square is here, to DC. And finally, AC is perpendicular to CD. So AC is perpendicular to CD. And do you notice that it says C, C, D, D, B, B, A? Because that's where they intersect. So these letters should match. Okay. In B, no right angles. That was easy. C, this is a right triangle. It only has one right angle or perpendicular lines. So DO, OG. DO is perpendicular to OG. So see how O is where they're perpendicular, where the right angle is formed. So that's why O is here. Well, this is an oval, no right angles. For E, this is a isosceles triangle. It's also an acute triangle because all 3 angles are acute. So no right angles. Now this is rotated, but this is a rectangle. So obviously there are 4 right angles. So we have PO, ON, because this is where the right angle is. So PO is perpendicular to ON. And then ON is perpendicular to NM. Oh, I did this wrong. This should be NM, because that's where they're perpendicular. So I actually did this wrong, didn't I? That's a mistake. And then NM is perpendicular to MP. So NM is perpendicular to MP. And finally, MP is perpendicular to PO. Let's see, what is this shape? 1, 2, 3, 4, 5, 6. 6 sides is a hexagon. No right angles. Whoa, this is tricky. H is tricky because some of the perpendicular lines are outside of the arrow. So this is a little tricky. So we have U, T, T, Z, because that's where they form the right angle or perpendicular. And then we have T, Z, Z, Y. T, Z is perpendicular to Z, Y. Y, X is perpendicular to X, W, right? Because that's an outside perpendicular. And then X, W, and VU. Well, that doesn't make sense. Not XW, it's WV. It should be WV. WV, VU. So that's wrong. It's WV is perpendicular to VU. Okay, so now we're going to use our right angle template. This is very similar to what we just did with the arrow. It just is kind of wider. So you're just going to mark them, and then how many perpendicular pairs of perpendicular sides does it have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. See if you can find all 9. And then true or false, shapes that do not have right angles also have no perpendicular segments. Well, obviously, if they're perpendicular segments, the definition of perpendicular is that they create right angles. So obviously, shapes that don't have right angles cannot have perpendicular segments, because right angles, perpendicular segments, they're kind of synonyms. So I just drew an acute triangle, which is isosceles because 2 of the sides are the same length. 1, 2, 3, 4, 5, 6, another hexagon, a parallelogram,